Hello, welcome. Thanks for watching. First of all, we want to say thanks to the Qt company to invite us on this summit. For sure, next year we will see our faces physically. We both work at Girbau at the R&D department, and my responsibilities are related with control systems. My name is Jordi Sanz.
Hi, I am Francisco Alonso. I'm the software architect.
And I am Bover. I also work in the controls team for this project and also on other research projects. Please, if you have any doubts during the presentation, you can ask in the chat and we will be answering.
We guess most of you doesn't know what Girbau is or what we do. Girbau is a company with many years of experience on designing, developing, manufacturing, and selling laundry equipment worldwide. We are located, the headquarters, near Barcelona. These last years, we also offer services related with cloth treatment. Some of our machines you can see on the screen. This is the middleweight series ranges, and we also have a heavyweight industrial ranges of machines. You can find that kind of machines in different laundry types: commercial laundry, vending laundry, which is the most visible for current people, and finally, industrial laundry. Today, we want to share with you our experience on developing a new control platform for a new washer series. We want to mention two pillars if you want to do a project like that: the background and the requirements. The background is that amount of experience that you collect during the years as a manufacturer. We started putting an electromechanical controls at the 80s. Then we added hardware and software, and we not only try to do good machines and good controls, we also try to understand the laundry business, and also we try to understand the interactions between the machines and the users. The requirements. The requirements are that list of headlines that you need to start a project. Some of these headlines are: we wanted a control with improvements in terms of connectivity and usability. We wanted to add Wi-Fi, Bluetooth, connection with card reader payment systems, and other protocols. We also wanted to comply with the standard regulations that means to sell worldwide. Regulations related with safety, with ergonomics, with other kind of standards like that. We also want to maintain what we call the Girbau Essentials. Girbau Essentials are that kind of mechanisms or philosophies that we have on our old controls, but we know that also could help on the future. Then we also want to make a sustainable project in terms of R&D. So we want to generate not too much technical debt. Finally, we wanted a control platform not only for a washer series, but also for other kind of machines: washers, dryers, ironers, and maybe others.
Thank you, Jordi. To continue with the presentation, I want to explain a little bit the overview of the project. First of all, we defined the users of our product. We choose three different segments which are very important for our company, which are the commercial laundry, the self-service, and the textile care. These are different customers that uses the product in a different ways. We also take into account the internal needs. We have users inside Girbau from the operations, installation, sales, and after-sales department. And those users are also using the product, and we have to make a good design also for them. This is about the customer. About the technology, we also take into account the requirements of technology. For example, on the drive system, we have a motor and we have an inverter. We have to check which are the requirements in this aspect. About the electric and electronic, we have to say that our product is complex and has many sensors, many actuators. We have to take that also into consideration. we also have to think about a modular project. As Jordi said before, we have different users, and each user may require different functionalities. We also have to understand the fluids and the detergents operations. Our machine has an input and an output of fluids and detergents. So taking into account the customer needs and the technology requirements, we defined a hardware architecture that is the following one. First of all, we defined a user interface, which you can see on the screen. This user interface, we have to design the hardware, the usability, and also the firmware and software class A. This user interface communicates with internal input and output boards, and those boards also require a hardware design and also firmware and software class B. This is the board that uses the safety. Also, this board is communicating with sensors and actuator, as you have seen in the previous slide. Qt especially help us in this part, in the usability and firmware software class A. And why we choose Qt? Well, for different reasons, but mainly 5 points. First of all, the user interface. We see Qt has a high potential in the user interface. It's a powerful tool. As you already know, you can use their own widgets, or you can develop your own widgets. We also choose Qt because it was very compatible with our Linux operating system. We are also using the cross-platform functionality for training. We are developing different apps for sales department and after sales to train the users on the new control. And we also choose Qt for the C++ language, which is a very familiar language for us, and also for the support, which is very good. Here you can see an example of the powerful interface we can achieve with Qt. We have 2 screens, 2 different user interfaces. In this case, this screen is used to start a program in the washer. It is the same functionality, but the user interface is different because the customer has different needs. In this case, we are talking about a commercial laundry and self-service. Here on this last slide, you can also see different user interfaces. Our customers like it because our machine is very programmable, and in this case, they can use it very easy. But I don't want to spend more time on that because Francisco will show later a demo.
Thanks, Eudald. Great explanation. Let's go. Key features in our software development are: first, software architecture designed with UML. The Unified Modeling Language is a general-purpose development modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of a system. Second, modularity. Modular design is a significantly faster and more cost-effective development. Third, multi-thread. 4. All variants are in a single project. And finally, strong testing. Modular programming splits functionality of a program into independent, interchangeable modules. Modular design also allows code to remain agile in the face of ever-changing requirements. A good modular design leads to some very powerful practical benefits. Understandability. A well-modularized system is much easier to reason about, think about, and communicate to others. Improvability. Strongly encapsulate modules maximize your ability to fix or improve individual module implementation without needing to update any other dependent modules. Refactorability. The less interdependence in a project, the easier it is to make large changes across multiple modules. Reusability. Modules are fully reusable. Whenever you have the same problem again, you can simply reuse the old solution. Testability. Modules with good interface and minimal interdependence are easier to test. And finally, scalability. To the most important benefit of modules, they let our applications scale. With our modules, complexity destroys productivity. The most important benefits of multi-threading design are: program not stallware waiting of broken operations, CAN communications, I2C, Ethernet. It allows multiprocessing. Multiple processes can run simultaneously. Software is multi-core ready. Thread-safe design. Upgrade CPU will be easier in the future. Now we show you a little demonstration showing the most important action of the interface in professional and embedded. The machine is totally programmable. For this reason, we work hard in achieving an intuitive and user-friendly front-end. We also achieve quick and smooth transitions between menus despite using a light CPU.
We want to share with you a market feedback. We want to share a real machine setup in a real vending laundry. We deliver the machine and the customer says, okay, the machine arrives, I'm too busy today, so he was not too happy. We turn on the machine and the corner, the RGB corner starts to blinking and showing the machine status. And the customer says, oh, that looks great. Then we explain what is our Sapphire platform. So what is our platform related with functionalities to do remotely with our machines. The customer saw the traceability, the potential, and his face starts to change a little bit more. Then we explain him additional features of our machine. We explain, for example, that in the morning the machine could be a vending machine and on the afternoon could be a current commercial machine. The customer starts to see the potential for this business. Finally, we reproduce a sequence of starting and paying for the washing process. The customer saw how easy and how fast you can start a machine. The customer also saw the additional extra functions that we add on the washers, and he saw the profitability for their business. Finally, the words of the customers are, wow, that's the machine that I really need. That's the machine that my business needs. Now we can share with you a video where you can see this control platform working.